Upthrust, Archimedes principle, and flotation. Upthrust is the apparent loss of weight experienced by objects immersed partially or fully in fluids. Upthrust is equal to the actual weight of the object minus the apparent weight in the liquid or gas. Archimedes' principle states that when an object is fully or partially immersed in a fluid, it experiences an upthrust, which is equal to the weight of the fluid. The summary of Archimedes' principle is upthrust on solid is equal to the weight of liquid displaced. That means upthrust U is equal to d sub L v sub 0 times G, where d sub L is equal to the density of the liquid, v sub 0 is equal to the volume of the object immersed, and G is the acceleration due to gravity. For partial immersion, say 2/3 of volume of solid immersed, then upthrust is equal to the fraction immersed 2/3 times density of the liquid times the volume of the object times acceleration due to gravity. Use of upthrusts. The relative density of a solid is equal to the weight of the solid divided by the upthrust on the solid. Second application. Relative density of liquid is equal to the upthrust in that liquid divided by the upthrust in water. Next is principle of flotation, which states that a floating object displaces its own weight of the liquid in which it floats. By this principle, weight of floating object is equal to the weight of displaced liquid. But from Archimedes' principle, weight of displaced liquid is equal to the upthrust on solid. Therefore, weight of floating object is also equal to the upthrust on the floating object. Example 1. A body whose mass is 2 kg and has a volume of 500 centimeter cube just floats when completely immersed in a liquid. Calculate the density of the liquid. The options are A, 4.0 times 10 raised to the power 2 kg per meter cube, B, 4.0 times 10 raised to the power 3 kg per meter cube, C, 1.8 times 10 raised to the power 3 kg per meter cube, and D, 1.5 times 10 raised to the power 3 kg per meter cube. The solution to the problem is as follows. Weight of floating objects is equal to the upthrust on the object. So we say weight of object is equal to upthrust. And weight is the mass of the object times acceleration due to gravity. The upthrust on the object is density of the liquid times volume of the object times acceleration due to gravity. With these informations, We can now fix the mass is 2 times acceleration due to gravity 10. Density of liquid was not given. Volume of the object is 500 centimeter cube. We need to change it to meter cube. And that means dividing by 1 million, 10 raised to power 6 times 10. By this, we now have 20 is equal to density of the liquid times 5 times 10 raised to power minus 3 of liquid equal to 20 divided by 5 times 10 raised to power minus 3. And this is 4 times 10 raised to power 3 kilogram per meter cube. By this solution, the correct option is B. Option B is correct. Example 2. An object of mass 400 grams and density 600 kilogram per meter cube is suspended with a string so that half of it is immersed in paraffin of density 900 kilogram per meter cube. The tension in the string is dash. Option A, 1.0 Newton, B, 3.0 Newton, C, 4.0 Newton, D, 5.0 Newton. The object immersed in paraffin experiences upthrust. The upthrust U is equal to half times the density of the liquid, the volume of the object times G, because half of the object is immersed in the paraffin. So the upthrust becomes half times density of paraffin 900 times the volume of the object is the mass of the object divided by the density of the object times G. So the upthrust becomes half times 900 times 0.4 over 600 times 10. Upthrust will now give 3 Newton. Having obtained the upthrust, we also need to know the actual weight of the object in air. But actual weight of objects in air is this, and this actual weight is mg. The weight of the object will give 0.4 times 10 Newton. The weight of the object is 4 Newton. Upthrust on objects is equal to the actual weight of objects minus the apparent weight of objects in liquid. So we have upthrust is equal to the weight in air minus the apparent weight. But apparent weight is equal to tension in the string. So apparent weight is equal to the tension. So we can rewrite the equation: upthrust is weight in air minus the tension. The upthrust is 3. The weight in air is 4 minus tension. That means the tension in the string is 4 minus 3 Newton, and this is 1.0 Newton. By this solution, option A is correct. Example 3. A solid of weight 0.600 Newton is totally immersed in oil and water respectively. If the upthrust in oil is 0.210 Newton and the relative density of the oil is 0.875, find the upthrust in water. The options are A, 0.600 Newton, B, 0.360 Newton, C, 0.240 Newton, D, 0.180 Newton. The solution to the problem is as follows. We are given the upthrust in oil, upthrust in oil as 0.210 Newton. We are also given the relative density of oil as 0.875. We need the upthrust of the solid object in water. Upthrust in water. We are looking for this question sign. There is a relationship between the upthrust in oil, relative density of oil, and the upthrust in water. And that relationship is relative density of oil is equal to the upthrust in oil as experienced by the solid object divided by the upthrust in water. So this is 0.875 is equal to 0.210 divided by the upthrust in water. Upthrust in water will now give us 0.210 divided by 0.875, which is equal to 0.240 Newton. By this solution or calculation, option C is correct. Option C is correct. Example 4. A cube of size 10 cm and mass 0.5 kilogram floats in a liquid with only 1/5 of its height above the liquid surface. What is the relative density of the liquid? Option A, 0.125, B, 0.250, C, 0.625, and D, 2.500. The solution to this problem is as follows. First, the volume of the cube. Volume of cube is equal to L raised to power 3. That will give us 10 raised to power 3 cm cube. The volume becomes 1000 cm cube. Also, mass of cube is equal to 0.5 kilogram, which is the same thing as 500 grams. From the principle of flotation, weight of floating objects is equal to weight of displaced liquid. Similarly, mass of floating objects equal to mass of displaced liquid. Therefore, mass of floating liquid, mass of displaced liquid, the mass of the displaced liquid is equal to 500 grams. Volume of displaced liquid is equal to 4/5 of the volume of the cube. So the volume of the displaced liquid is 4/5 times 1000 cm cube. Divide this will give us 200. Volume of displaced liquid is 800 cm cube. Having obtained that, we can now get the density of the liquid. Density of liquid is equal to mass of the liquid displaced, mass of the liquid displaced divided by the volume of liquid displaced. So that density of the liquid becomes 500 over 800, which is 0.625. Relative density of the liquid is equal to the density of liquid divided by the density of equal volume of water. And that will give us 0.625 divided by 1, which is 0.625. By this calculation, the correct option to the question is option C.